One of my favorite roller coasters is the Leviathan in Canada's Wonderland. Imagine you're on the Leviathan and you're going up on the highest hill, which is 9,300 centimeters high. When you're at the top, the 4,500 kg train you're on stops completely, and then you go down so fast. But exactly how fast? Let's start off by writing out what we have, which is the mass of the train and the initial height. We know that the final height will be 0 because the train will be at the bottom. I also said before that the train is at rest at the top of the hill, so the initial velocity is also 0. Since we don't have any external forces besides gravity, because we're assuming there's no friction, we can use the law of conservation of energy. Initial energy equals final energy. By expanding that, we can cancel out the initial kinetic energy and the final potential energy because we know that initial velocity and the final height equals 0. Now we can sub in the values we have to solve for the final velocity. Therefore, the speed of the train when it goes down the hill is 42.69 meters per second in the downwards direction. We can use the law of conservation of energy again to find the gravitational potential energy. We can cancel out the final potential energy since we know that it equals 0 when it hits the bottom. And we can cancel out initial velocity since it's at rest. Subbing in our values, we get 96,062.09 joules of the gravitational potential energy of the train. Now the train is going up another hill with an initial kinetic energy of 3.65 times 10 to the 6 joules. Using the same method, we can find the final height, which will be the height of the hill. Canceling out the initial potential energy and the final kinetic energy, we are left with the final potential energy and the initial kinetic energy. We can expand the potential energy to mass times acceleration due to gravity times the height. Now we isolate for h and get 82.77 meters. Because the mass of the train is constantly the same, if the speed is increased, the kinetic energy will also increase. Since the fastest speed occurs when the train is going downwards, the kinetic energy for the roller coaster is the greatest at the bottom of the largest downhill slope.